There's nothing that could possibly go wrong.
Well, at least it's a backup, right?
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 250. We'll be talking trains, RC planes, and EEPROMS in flames. This week in the news, I am off at Chaos Communication Congress, and it is absolutely insane. 14,000 hackers all together in the Hamburg Convention Center, which is actually kind of fun because the Congress used to be here, and then they had to renovate the building, and so we had to go somewhere else for a while, and then there was a pandemic, and now it's back in the old building, and it's kind of fun. It feels like old times. If you're here, you already know what's going on. But if you're not here, I've got a link I'll throw in the show notes for you. But also, we'll put some links to some of the really amazing talks that are going on. In fact, I wrote one of them up. We'll cover that in a minute. The really nice thing about the CCC is that they have video of the talks up as soon as the next day. So if you're not here, you can also follow along by heading over to the website and checking out anything that looks interesting to you. I don't know. I looked through, there's at least 15, maybe 20 talks I want to go see. And I've managed to see 3 so far. But it's always like this when you go to conventions. You can never see as much as you wish you could. On the other hand, I was able to get us a CCC-related What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
So you want to give it a listen?
I was heading for something solenoid related at the beginning, but the end didn't make me think that's correct. So I don't know. I'm just going to take a random stab and say it's a paper tape punch, but that's not right.
I'll give you one hint, and that is that there are 2 different versions of the same thing. So those were 2 distinct sounds from 2 different kinds of a blank.
I'll tune in next week.
Sounds good. I'll probably tell you before next week. But if you're listening at home and have a good guess as to what these things are, head on over to hackaday.com/podcast, fill in your best guess, give us your handle, and we'll see who guesses it right next week. All right, so with that, let's head on off to the hacks. I'd like to start off with an amazing story from the Chaos Communication Congress, where I am. This is a talk given by Redford, Q3K, and Mr. Tick, Unbricking Trains, Uncovering Shady Behavior. This is just one of those incredible hacker stories that you kind of have to see to believe. You really should all go watch the talk. The link is over on the Hackaday page. The long and the short story is that a company in Poland that has a contract to repair and service locomotives couldn't get them fixed and working and wanted to know why. And so, according to them anyway, the company Googled Polish hackers and came up with Redford, Q3K, and Mr. Tick's names, called them up and said, hey, we think there's something with the firmware on this train, ECU controller thing. Can you poke at it and see if you can make these trains run again? And they said, yeah, we'll give it a shot. And then they're like, oh, by the way, you have 2 weeks to do it. In fact, they managed to get the trains running about 43 minutes before the deadline they had been given. So trains are basically run entirely over CAN bus and are programmed in this kind of weird, archaic programming language. They managed to sniff the CAN bus and find out that it was sending some zeros, essentially, where it should have been sending ones. That is, the controller was telling the motors not to fire up when they should have been spooling up, even though they were throwing the lever up front. And the reason for this is that it looks like, from reverse engineering the software was intentionally bricking itself. The software was intentionally failing after a certain period of time. And they ended up having access to, I think, 30 individual locomotives and dumping the firmware from all of these, reverse engineering it, looking at it. Not only could they make them run, but they found the code that made them not run, which included things like if it's the 21st of the month and the train hasn't run in 4 days, don't fire up the motors. The absolute best, as far as I can tell, which made this very clearly kind of an act of, I can't say it's an act of sabotage. This is an ongoing legal case.
Malfeasance, perhaps. Yes.
Apparent malfeasance.
Alleged malfeasance, yes.
Is that the manufacturer put things in there like geofencing against a bunch of their rival companies that were servicing the trains to make them not work when they were in their stockyards, but able to work when they are elsewhere. And in fact, they had a flag that made it not work when it was in their own stockyards, but they also were able to turn it on and off. So they had tested this geofencing thing, apparently, and then implemented it in actual real trains. And so this is just a phenomenal talk, and it kind of brings home the best of the reasons why we hack. And that is, some companies will do technologically bad things. And if you can reverse engineer their firmware, you can figure out that they're doing this and hold them accountable. And that's exactly what happened here. But go watch the talk. Trust me on this one.
So I did think the geofencing out your competitors' repair yards was particularly egregious.
That's awesome.
Because up till then, I was kind of like, well, let's try to be open-minded. Maybe they have a reason. But that seems over the top. And I think I always have a resistance to getting the courts involved in anything like this because that's never good, right? It's just, usually the courts do not make great decisions about technical stuff. Going all the way back to the, you can't see the copyright message in the ROM, so therefore it's not copyrighted. That was back in the 70s or whatever. But, this does seem like a big deal. And I could not help but think of the McDonald's ice cream machine fiasco, right? Which has a lot of these same sort of shadows in it where, you say, well, we did publish the codes, but nobody bothered to read them. And so when somebody made a Raspberry Pi to read them, we didn't like that. So then we started, saying, oh, it's not safe and it might be dangerous. And, I don't think it's dangerous to have a Raspberry Pi connected to your ice cream machine. So it did kind of remind me of that. And it's the same kind of thing. Once it devolves into a legal battle, it just seems like nobody really wins except perhaps the lawyers. But I do agree, this seemed to be especially egregious and maybe even more mean-spirited than the ice cream hack. So
they looked at all of these trains, and they all had different triggers in them. Some of them stopped working after the odometer got to 1 million kilometers. Some of them stopped working after the train was inactive for more than 21 hours. Some of them stopped working on the 21st of the month. And that one, there was actually a bug in the code, and tongue-in-cheek, Q3K suggested that the 21st be a Polish national holiday, the day the trains don't run. And I thought that was pretty sweet. Oh man, there's so many crazy details in this talk. One of the things that I really love also is that they had access to one of these units, they dumped the ROMs, and then they sent it back to the manufacturer and told them a little bit of what they had found and what the problem was. The manufacturer sends it back, working, of course, with a new firmware that has, as you mentioned, strangely enough, copyright notices in the ROM and says, if you're dumping this ROM now, you're breaking the law or whatever, right? And the funny thing is they changed a number of other things. It's probably illegal to change the ROMs on the ECU of a train without getting it recertified. So it's very likely that not only did they do something that is, trying to cover their tracks and protect them legally from this incredible storm that's about to hit them, but they probably also put trains back on the rails that did not have properly vetted firmware in them.
I'm not sure what the safety regulations for trains are, but you would think there'd be something. Certainly like an airplane, you couldn't do that. You can't just say, oh, here's some new firmware we slapped together. Let's throw it on an airplane.
They hid cheat codes, essentially, in the firmware that reactivated the motors and stuff like that. I mean, because they didn't want to do tons of work. They didn't want to have to reflash the firmware to get the trains running again. So there's actually a 2-lever command sequence you can give the train, and then it'll start running again. And that's actually what these guys found out about all these trains. They actually didn't end up changing any of the firmware on the trains. What they did was they read it, dumped it, reverse engineered it, discovered the cheat codes that were embedded in the firmware, and then just replayed them, push this lever here while pressing this button and hitting the brakes. And then that made the train run again. Yeah.
Well, and it kind of reminded me, too, of some of the old copy protection schemes that you used to see on, like, games. And if you dig down far enough, there was always some piece of code that said, did I see my copy protection? Yes, no. And you could always at least reverse the sense of that, right? So so then it wouldn't work with the hardware dongle or whatever the protection device was, but it would work without it. For a long time, that was a big emphasis on people hacking, was finding ways around the copy protection for games. It kind of reminded me of that a little bit.
Well, glad those days are gone, but that kind of behavior is absolutely unacceptable in large public sector infrastructure.
So I waxed nostalgic for my first one this week, and it was actually a piece that Chloe Abenisu, I think, at PC Magazine wrote, which was a tech obituary for all the tech gadgets and services that died in 2023. And most of them were really consumer oriented. Google obviously had killed 20 things like they do every year, including, I was amused to see Google Glass died again, because I guess they had a commercial version of Glass that nobody wanted either. That's one of those things where, man, sitting in a room somewhere, you would assume that would just sell like gangbusters, and it just doesn't. And I don't know, there must be some larger reason for that. But it ranged to other things too. Netflix apparently stopped shipping DVDs, which I didn't know they still were shipping DVDs, and just a lot of different things like that. But it got me to thinking, those were all really kind of consumer oriented, and we're all kind of interested in that. But it really made me think about what have we lost in our sector, right, in the hacker space. So what products have kind of come and gone? Some of the 3D printing stuff has started to fall out. So XYZ printing, they were infamous for having the closed filament. They're gone. I guess the Sculpteo marketplace was gone. And I was hoping in the comments maybe people would know about some other little obscure things that had come and gone. But surprisingly, I didn't see a lot that just made me think, oh, yeah, that's a big thing. But I think there's a lot of changes in the industry, and maybe we're due for a shakeout. So maybe 2024 there will be more things shaken out. And I think part of it is we've got so many big players now that maybe the things that kind of came and went, you didn't even notice. So it's one thing when Google shutters something down because they're very visible. It's another thing when, the Williamses start their garage company and it just doesn't go anywhere and they go back to writing for Hackaday, right? So, I think that's maybe less noticeable, but I imagine there's a lot of that going on as well. I think the other thing that was interesting to me about this is the fact that, we are seeing a lot of stuff that's subscription based seem to go away. So, Google, back on Google, since they kill everything, they had offered the deal where you say, oh, if you pay us so much a year, every couple of years, we'll give you a new Pixel phone and you'll get free access and, all this stuff. And I guess if you signed up for that, tough, because they kind of canceled it. That's interesting too, because I fear we won't sell you anything. We're going to give it to you as a service, some because of what we just talked about with the trains, right? Because once you own my phone and I don't, you can justify getting away with a lot more naughty things on my phone than if I own it. But it seems like maybe the market is rejecting that. So that was kind of a cool takeaway from that, I think.
I'm looking down this list on PC Magazine, and, if I get to be hardware guy versus software guy, I will note that these are like 90-something% software that got discontinued, or like you said, there's software services that got discontinued. So few of them are actually, physical things out there in the world. It's just like, we thought we would sell you this software and now we're not anymore. And, yeah, well, easy come, easy go, right?
Well, I mean, Google Glass certainly was a piece of hardware, but you're right, it's in the minority.
I don't know if their business model was, I guess they sold it to you for outrageous sums of money. So they probably were counting on it being, the hardware pushing the device.
Well, not that I'm in any position to give Google advice, but it always strikes me that they don't have the lesson we learned back with the CP/M computers, which is that no one wants to buy computers. They want to buy applications, right? So you didn't really buy a computer. You bought WordStar and you bought VisiCalc or whatever the early spreadsheet program was. And so it seems to me that's what is missing here is you don't need the, hey, isn't that cool? There's glasses and you can do a web search on them. You need the killer application that says, hey, I'm a surgeon and I can get a tactical view of my patient laying on the table through these glasses or whatever. I don't know what the killer app is, because if I was, I'd probably be doing that instead of this. But
Yep.
that's what will sell it, is when there's the app, you just can't live without it and you'll pay anything for the glasses. Just saying I made the glasses, only we get excited about stuff like that.
I think you're right. I think it is you're saying app like software application, the killer app, but I'm saying, what's the real physical world application? But we're both saying the same thing.
Right. And I mean, it's just like if you say, look at the early computers when it was just the weird people that had them, and you said, oh, we did my biorhythms and I kept my recipes on them. And, I don't have to say, well, why do I make this recipe for 6 when it's for 4? I just tell it I want 6 people. No one cared about any of that, so that was there, but no one cared. And what people really cared about at first were the spreadsheets and the word processors. And eventually the real surprise is they were interested in music, media, and talking to each other, right? And that turned out to be the killer app was not just having a computer, but having your computer talk to everybody else's computer.
Well, it's winter time here, and that means the fall semester is over, and that means Cornell's ECE 4760 class. This is a microcontroller class where the students all have to, through the course of the semester, put together a final project and show it off on the internet. This class used to be run by Bruce Land. It's now run by Hunter Adams, but these student projects are no less awesome. So expect to see a bunch of them coming out in the next few weeks. The one I wanted to cover is Raspberry Pi Pico Mandelbrot computation. And this is a really cool project done by Ryan Colm and Ignacio de Jesus Romo Jimenez, in which they set up a parallel computer that they're calling the Computron to calculate the Mandelbrot set and display it on a VGA monitor. The Computron is a parallel computer in the sense that they have one Pico that's responsible for doing the graphics and projecting that onto the VGA monitor. And then they can plug in a whole bunch of other Picos with kind of compute software on them and spread up the work amongst them. They all talk over an I2C bus, which provides a simple kind of robust data backbone for them. And then the main computer prints it out to the screen. Their write-up is superb, and it ends up coming to the conclusion that a lot of people come to when they're like, I'll just take this problem and parallelize it. And that is that you really don't get a n times speed up if you throw n computers at the problem. And they find that in spades here. They get kind of, an 80% increase in speed when they go from 1 Pico to 2 Picos working on it. But they have a beautiful graph where they show it taper off. And in fact, they have the really strangest thing, which is that sometimes they'll have little jumps in their performance where you would expect the performance to keep increasing as you throw more processors in it, but it doesn't, or it stalls. And what they think is going on here is when you divide the problem by 2, it's pretty evenly split among the 2. But when you divide it by 8, one of the processors gets the hardest problem every time through as it goes through this kind of round robin, you take this slice, you take this slice, you take this slice procedure. And that poor one processor, long story short, it's so tempting to just throw massive parallelism at a problem when you have a problem like this, especially when you have like cheap devices. You're like, I need it to go twice as fast. I'll just use 2 of them. No, you'll use 3 of them. And then it's like, I need it to go 8 times as fast. I'll just use 8 of them. And the answer there, I think, is you're going to have to use 32 of them or step up to a bigger processor.
The I2C bus almost had to be some factor to that. You normally see some sort of higher end fabric or shared memory, but this was such a great effort for a student project. And it's always one of the high points of the year when Cornell sends over their batch of student projects, because it's always amazing. And this one certainly was very interesting. They sent it over in a block, and I think there was like 47, I want to say. There was some huge number of projects. But a lot of them had pretty interesting titles, gesture-based game or something. And some of them would say like Computron, and you're like, well, I don't know what that is. So part of our job was to kind of dig through and go, oh, this is where they used a bunch of Raspberry Pis in a parallel processor, and then that's what Computron is. So, that might be part of the student work there, is to make sure we understand what you're doing. So,
Oh man, you give me a project called Computron and I am digging into it. I'll be like, that's bait for me. I'm like, what the heck is a Computron? What I really love about this Cornell class is that all the students who take it are graded on both the success of their project, but the quality of their documentation around it. And that's, I think, why we've been covering these projects for so long. I'd be really stoked to see other engineering programs follow suit. I mean, I'm sure that other schools out there must be doing things like this, where they give them an end of the semester capstone project. And it's like, how cool can you do this? But by requiring the students to document their project and make it available to everyone else, it not only helps each successive year of students do cooler and cooler things, which we've totally seen in the kind of 10 years, 15 years that Hackaday's been covering this ECE class here. So the students get to benefit from each other's work, but then we get to write it up too. And then everybody gets to benefit from the students' work. And I think that's really what's super cool about this particular ECE class. And why are other professors out there not requiring their students to document their work well and put it up on the internet? If you do, it offers them a fantastic carrot, right? Like, if they want to put that extra effort into it and make it look really good, or put more work into it and document that super well, it just makes such a huge reward for them in terms of the ability for them to get recognition for their hard work over and above just getting an A in the class. Yeah, if you're an engineering professor who has your students do like a practical class like this, give them a documentation requirement and send us the links. We're dying to see them.
well, and I don't know about you. If I'm interviewing somebody and they said, "Oh yeah, I've had 3 projects featured on Hackaday," I'm hiring them, right?
Oh, I swear. I mean, look, featured on Hackaday or not, going on the job market can point to this work and say, here, look at this. And that's like,
Absolutely. Build your portfolio.
it's an interesting thing that you've done. It shows you're, competent and well-rounded and who knows what else. Like, it's a win-win for everybody. It's like 7 wins.
Okay, my next pick for the week was from Keep Making. It's one of these things, after you read about it, you think, why didn't I think of that? You've known for a long time that if you're going to 3D print some stuff, it makes sense to fill up your build plate and try to print as much as you can in one pass. And you're thinking in X and Y, but this article is talking about actually filling up the build volume in the Z-axis as well. And that's apparently not a super new idea, but you don't see it very often. The idea is kind of to print pieces that are separated by just a single layer gap with ironed top surfaces. And it's almost like printing support pieces, except instead of the support just ripping off, you essentially rip off finished pieces and then rip off more finished pieces and rip off more finished pieces. The videos were really well done in that you could see how they were kind of stuck together. He'd take a screw and just use them to pop open the little pieces where it was still stuck together. Obviously, one side of the piece isn't going to be as well finished as the other. In this particular case, he's making things that hang on the wall, so you really don't care what the wall-facing side looks like as long as it's not too grody. It didn't look like it was that bad to begin with. So I'm kind of interested to try that out myself. I don't always do large volumes of prints, where I'm printing 50 things at one time. But that gives you a lot of options for producing more things than just going to the right, the left, up and down on the bed. Of course, I don't know if you could do this with resin printing. That has its own advantages because then, filling up the X and Y on a resin printer is easy because it doesn't take any more time to print an empty bed than a full bed. But obviously, this would add time in that case if you're going up in the Z-axis. But I don't know if those would separate quite as well or not, but it'd be something interesting to experiment with.
I guess it only works for things that are kind of relatively flat in a way, because if you have too much kind of vertical topology, it means you'll have to think about putting fill in between the different object layers. It's a really neat kind of switch in your thinking to think about multiplying the things, not just left and right, but also up and down.
It made me wonder if the slicers couldn't support something like this, where you could actually, build little support pillars in between the layers, just like you do now for tree support, for example. That could all be done automatically, and you could get nice stacks, even if they weren't flat, like you suggest.
Oh, that would be super clever. And if you had holes in it, you could even you could run supports up vertical holes and tubes and stuff. Oh, that would be really neat.
Yeah, a lot of fun things to think about there.
All right, bringing up the rear for me, absorbing traffic noise with bricks using Helmholtz resonators. And I think if I had my life to live over again, one of my crazy dream jobs has always been kind of an acoustic architect. There are people who get paid good money to design symphony halls, but when I walk into a number of other spaces, I'm always kind of like, sometimes they have really harsh echoes, and sometimes spaces are so loud you can't even hear the person you're talking to, and traffic noise can be overwhelming. And if you have, big flat walls, it can kind of get seemingly amplified. That's kind of the project that is being undertaken here, is how to beat that down. And in particular, he's using cleverly designed stackable bricks to absorb some of the energy out of the waves and put a notch into the level of noise in an environment. In this demo, he's using clay as the material and making kind of bricks that have cavities in them that want to resonate at certain frequencies. But then because the bricks aren't, perfectly hard, they absorb all of the energy in those frequencies. So you can think of it, like kind of any tuned system, except a tuned system where there's a lot of resistance, so it dissipates the energy out randomly. And it's a really neat design here. He starts off by doing 3D printing to make these kind of extremely complicated clay brick shapes that have exactly the right interior volume to absorb kind of low frequency road noise. And then they end up cracking. There's a whole bunch of reasons, and he actually goes through 3 or 4 kind of failed iterations here. He ends up slip casting into 3D printed forms to make the bricks, and that ends up working. The thing that is really clever about the design he ends up settling on, and this is why you'd want to do it using modern design techniques, is that they have not only a resonant cavity inside the brick, but they're shaped on the outside so that the spaces in between them also makes a resonant cavity. And because of this kind of irregular shape, you can only stack them in exactly the right way to make these shapes, both the interior and the exterior one. It's a really sweet design. And if you've never thought about how you would go about making hollow, arbitrary shaped funny bricks, like that's a cool problem to have and to have to solve. And he goes through his work in that direction here too. Really just a fun talk. You should check it out.
Well, I'm always surprised at how poorly I can predict what comments will be on any particular Hackaday article. If you read the comments on this one, they're almost to a one saying, well, that's great until the possums nest in those hollow cavities, right? Or the, insects, birds, pigeons. That probably has some merit to it. I'm not saying it's insurmountable, but yeah, it seems like they would be a maintenance issue. But yeah, what an interesting exercise in shape. And, I don't know. I'm not as talented as you are with hearing the echoes, but I will say a room with good acoustics is a thing of joy. I don't always understand why it's the way it is, but certainly makes a big difference.
Acoustic architecture. I'm sure it's a field. I'm sure there are people who make their living doing this. In some alternate universe, I'm one of them.
My last one this week is from Veritasium. I have to say, this is probably something that won't surprise some people, but for me, I have had this lifelong obsession with how in the world does a sewing machine work, and I just have never taken the time to figure that out. It's one of those things, I think Hackaday readers in general, we like to think we know how the world works. So why does your cell phone work? Why does air conditioner work? And we usually know those things. But I was never able to really understand how a sewing machine takes a needle, jams it through some fabric, and stitches it together. What was interesting about this video, it was very accessible, but also he had built a large-scale demonstrator with a needle the size of a garden stake, I guess, and big giant belts and pulleys, and the thread looks like more like twine, and is able to demonstrate all the different working pieces. It's amazing when you think about it is, if you said today, let's make a machine that binds fabric together, well, you got a lot of options, right? You could say, well, we'll get a stepper motor, we'll have some little arm that goes and pulls this here and there. All this was back in the 1800s and earlier where you didn't have all that. So it's all these clever contraptions with cams and hooks. And I just thought it was a super interesting piece. And I'm certain I'm in the minority of people who didn't know how a sewing machine works, but I was really happy to run across this. It's something that's been in the back of my mind for years.
I'm certain you're not in the minority. It's a pretty crazy mechanism. And, the rotating claw that pulls the loop through is just, I would not have thought of that a priori.
Well, you got to wonder how many iterations it took to get to that too, right?
That's right.
How many times you said, oh, that didn't work. Let me try this shape. And you couldn't 3D print them in those days. So that was probably a lot of work.
And the advantage to being able to make a working one was so huge. Like before, when everybody had to sew by hand, you'd be king of the world if you could make a machine that would sew.
Well, that was actually one of the things that was in the video was he was saying, and I don't know what the source for this is. He was saying that in 1900, a family would spend 15% of their income on clothes. But in 2003, that number's less than 4%. And yet you will have way more clothes. The family will have more clothes in 2003 than they had in 1900. But yeah, people made fortunes, and especially it was kind of interesting. Singer, who you associate with sewing machines, he didn't actually invent any of it. He just saw the value of it and bought up patents and commercialized cheap sewing machines, and that's where Singer came from. Not to mention 50,000-year-old needles. Good God, who was thinking that up 50,000 years ago? That's amazing.
People been sewing for a long time. All right, my first quick hack this week is veteran SpaceX booster lost to rough seas. And this is a piece of news coming from SpaceX, naturally, written up by our own spaceman, Tom Nardi. What happened is they landed one of their boosters, as they often do, except this time, due to rough seas, it fell over and got destroyed. But the booster in particular is one that had made 15 launches, including some historical ones. So Tom wrote up a brief eulogy for B1058 here. Give it a read. It's an interesting view into kind of the new space situation. But speaking of old space, Liftoff, the origin of the countdown, is a long-form piece written by Christina Panos. I'm mentioning it here because of the super cool tidbit that the countdown may have been invented for drama in a film before it got used for launching actual rockets. Turns out to be useful, of course, gets everyone in sync on the same page, but this is a case of life imitating art. And last up, Tom Stanton building a rad supercapacitor RC plane. This is really fun, despite the fact that supercapacitors have a lot less energy density than a comparable lithium-ion battery. Tom wants to make one because he already has a hand-cranked charger generator to fire it up with. And supercapacitors charge and discharge very easily, very readily, and can put out large current, of course. Here he's turning it into a radio-controlled plane that he can just go zip, 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 charge it up at the field, and then give it a fly. He also deals with the real downside of supercapacitors, and that is that their voltage basically starts dropping from the minute they start discharging. They have a capacitor-like voltage roll-off, and how you deal with that and get the plane home safe when the motors can't turn anymore is an interesting problem that he looks into here.
My 3 quick hacks for the week. Danny Lewis had an interesting post about how to build a guitar for $30 using parts from Amazon. So all my cool friends build guitars. I have no musical talent, so I don't, but I always suspected it would take more than $30, and this article shows that that's not necessarily the case. My second one was another one of Hunter's students' projects from Cornell. Giacomo Cuomo and Sophia Lynn had a talking ohm meter that spits out color bands for you. And, I kind of described it as a multi-mode ohm meter in that it measures resistance and it's able to actually speak the resistance, but it also has like a giant model resistor with multicolor LEDs on it. and it actually shows you the color bands on the fake resistor of what the real resistor value is. It's one of those projects that's probably not very practical, but very cool. Last but not least, Diode Gone Wild. I always loved that name. Had an interesting video on how wire changes resistance by temperature and how you can use that to measure temperature in circuits. So, obviously that takes a lot of wire and or a very precise resistance measurement. But if you ever wondered, how hot is that transformer getting, that's one way to do it, is to measure the change in resistance in the wire in the winding.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I wanted to pick Dan Maloney's Keeping Watch Over the Oceans with Data Buoys. And this is another one in the series that, at least among us Hackaday writers, he's calling remotely interesting, which I love. I wish he'd use that in print, because these are all remote measurement devices and how they work. In this case, he's talking about ocean buoys that both measure temperature, wind speed, wave height, all sorts of things, and help give us a better picture of what the globe's weather is like, especially out over the seas where it's otherwise harder to measure. The thing that I learned from this that I hadn't thought about before was how hard it is to connect, to moor deep sea buoys to the ground. And in particular, there are all these like multiple material, multi-section cables that you have to use if you're going down really deep. Because if you think about it, naively, I'm like, oh, well, they just must have a chain that goes down to the ocean floor. And yeah, that's fine if the ocean floor is like 30 feet down. But if you've got like miles and miles, or even just, hundreds, thousands of meters of steel cable down there, that's clearly not going to do it. And so they end up using these fun mixes of nylon and polypropylene lines that float better than nylon lines, and all of these with floats on them. There's a whole engineering problem in designing the mooring systems that keep these buoys basically in the same place. I thought that was really neat. Of course, there's all the standard stuff like how you design the buoys to be rugged enough that they can withstand high seas. And Dan actually points it out in one of these. There's a buoy with a cage on it that prevents seals from climbing up on top of it and maybe messing up the instrumentation. Like, these things are put out in the roughest environment for electrical devices, right? Like the middle of the ocean with nasty waves. And then they're supposed to be tethered to the ocean floor, stay basically put, and they need enough electricity, enough generating capacity, whether gas or solar, to keep running and keep sending their data back to us here on the land. So it's a really neat problem, and designing scientific deep ocean buoys is just one more of those kind of remotely interesting sensor things, and I'm happy to read this one.
Yeah, this got me nostalgic because one of my first jobs was at the same place where NOAA had a big operation for data buoys. I didn't have any direct involvement in it, but back in the late 70s, early 80s, this was way more difficult than it is now. And, they had all the problems with sending data. So you had very precise time measurement. Now, we didn't have GPS, right? So you had to figure out the time so that when your 1 minute of data on the satellite came up, you could squirt that data up over the satellite and not interfere with everybody else who was going to be using a different minute, things like that. So my guess is things are a lot easier now. So I know if they're close to shore, sometimes they use cell modems, and that was all unheard of in those days. They do have a lot of free floating buoys as well. So even though, you're right, it's amazing what all they do to anchor something in 6,000 meters of ocean. Some of them are actually just floating around. And, one of the things that I don't think Dan mentioned, but one of the reasons I think there's a lot of money put into these is, at least at a certain point in time, they were very interested in the ocean conditions for where the submarines might be coming over, and that was a big part of this as well, was picking up data about ocean salinity, thermoclines, things like that. So I feel like there was probably some other non-civilian use of some of this data, at least over part of the time that it was operational. But it's an amazing network. And yeah, Dan did a great job of writing it up. He did mention, by the way, I was also dismayed he didn't use remotely interesting in the title, but he does say towards the end, he said something about other remotely interesting articles. So I guess he's kind of got that as a series, but it's not actually in the title. So we ought to fix that. We ought to at least make it the series name.
Well, he's actually tagged them all as a series retroactively and put them all down at the bottom of this one. So if you're interested in following them out, you actually can find them in this one or any of his others in the series. I think two I just wanted to shout out real quick were his No Snow, monitoring snowpack with the Snowtel network, because that's a particularly cool device. And then Feeling the Heat railway defect detection system, where they basically have heat cameras that look at train wheels as they go by and see if they're getting too hot, which would indicate that a bearing's busted or something. Both of these are really, really cool, and they're kind of, pieces of essential remote sensing infrastructure that keep the world running smoothly, but are somehow, I hadn't known about any of them before reading these articles. So to that extent, at least, invisible to our normal everyday experience.
Yeah, there's a lot of strange stuff out there.
Yeah, I can't wait to see what he comes up with next.
Well, my pick this week was Lewin Day. How do you test if an EEPROM can hold data for 100 years? This is always an interesting topic to me. I spent time working for Motorola where we did this kind of stuff. And, you say, well, this flash memory will hold data for 100 years. Well, we haven't had flash memory for 100 years. So obviously somebody's making a guess. And how do they do that? Lewin does a great job of explaining failure mechanisms and say, well, okay, as the electrons bleed out of this, or the charge bleeds out of this gate, that's going to get worse over time, but also as the temperature or the humidity or whatever. And so you wind up designing these tests where you say, okay, me heating this up to, 150 degrees is going to be the same as if it was at room temperature for 20 years. So now if I can get it to last 5 years, I can safely say it's, 5 times 20, 500 or 100 years. And whether or not that's really true or not, I don't know, because I don't know if anybody's ever actually gone back to see if any of that works. We barely have enough time on some of these devices that maybe you could start actually looking at were those predictions accurate or not. It's kind of interesting, though. They use that for a lot of things, which I didn't realize. They use it for archival paper and inks, which I learned that reading this. But at the end of the day, it's kind of a estimate or a model, if you will. So, when you see the science fiction show where, 700 years from now, somebody pulls out something and it's still working and you say, that flash drive wouldn't have lasted that long. Maybe it would. We don't really know. But certainly the data suggests that it wouldn't. And how you actually got there is what Lewin kind of exposes. It's well worth the read if you've ever wondered how those numbers are arrived at.
And what I like about this is it is kind of based in fundamental science at the end. He says in this article, and I guess I hadn't thought about it, that like bit rot, degradation of memory cells, is basically because of chemical reactions that are going on inside. And that gets you the answer already, because chemical reactions increase with heat as described by the Arrhenius equation. And so, you can figure this out, right? Like you increase the temperature by 10 degrees, the reaction speed goes up by this much, et cetera, et cetera. And this is true for chemical reactions, so that means it's true for how quickly materials oxidize or things like that. I don't know if it's necessarily true for how quickly, trapped electrons diffuse through a silicon barrier. But actually, now that I think about it, it's got to be, right? Like, this is chemistry again. So it probably makes a whole ton of sense to think about things this way. I guess you could also think about whether some of the bit rot is due to cosmic rays, and then you'd want to subject them to some X-ray bombardment or something for what do I know, right? But the basic science here, I think, is really sound in the sense that they're saying, look, this has got to be a chemical reaction that's causing the damage here. And so we know at what rate chemical reactions speed up given different temperatures. Let's just crank the heat up on it. And of course, that only works till the thing melts.
Yeah, you've got to wonder, and maybe this is a good science fiction story in 1,000 years, what the archaeologists are going to make of all this, because presumably all of our storage media will be pretty much impossible to read then. So it's like, what is this? I don't know. It must have had some religious significance, No, it's a CD-ROM, but no one knows how to read it, so you can't see the Panda movie that was on it or whatever. Maybe not. And it makes you wonder too, just like we have techniques now where we can pull writing off of things that they used to think were lost forever. Maybe they'll have some way to do something we don't know about and figure out, oh yeah, this is what used to be stored in that flash memory or on that piece of magnetic tape. Who knows what they'll develop. So
If you want it to last for 10,000 years, write it down on paper in some good ink, though. I have a whole closet full of like CDRs that are just rotting away right now. I don't even dare look. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you'd like to follow the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, write us tips@hackaday.com. And until next week,
keep those hacks coming. What's the German word for piece of crap software?
crap, why did I do that? Give me 1 sec.
I knew you were going to do that. I should have looked it up for you.
Capacity. It says supercapacitor, and then I say capacity.
Well, apparently my phone's off mute. I hope that didn't come through on the audio, Elliot.
I think this is episode 250. Wow. That is almost a milestone.